So, sorry, it's yelling at me for space again. What we're going to do is find our derivatives at each of those points. So our points of intersection of the original curves. So I'm turning off my derivative curve. I'm turning off my line. I'm turning back on the originals. And I'm going to find their points of intersection. And again, they gave me those graphs, so I know there's one, and I know it's like right here. So I know there's one right there. It's at 0.9419. So if they intersect at that point, then the equations of their tangent lines needs the slopes at those points. So I'm going to go second quit. I'm actually going to arrow back up because I already kind of typed in my derivative for y1. So I'm going to click this. I'm just going to type on top 0.9419. That's going to give me the slope of the tangent line for the first graph. So it's y minus, here's my slope, x minus, we know where they intersect. What I didn't know is actually my y value, so I got to get that from my table. Then I'm going to do it again for the second graph. And what I'm going to do is just highlight this again, hit enter, and I'm just going to change now this. So I'm going to hit vars, y vars function, and go down to option 2. And then I'm going to hit enter. So I get 0.808. X minus 0.9419. And then to get my y values, I'm going to go second table, 0.9419. And I get 0.4118. And again, I'm finding their tangent lines at the slope or the point of intersection, so it makes sense that the y1 and x1 for each match. And then the last part is find the area of that region. So to find the area of the region, we're going to do top minus bottom to that point of intersection. So it's 0, 2.9419. The top equation, which is e to the negative x squared, minus the bottom, which is 1 minus cosine x dx. So on your exam, I would write it out like that, and then I would go to my calculator, go to math, go to 9, go to 0, 0.9419, then hit vars, y vars function y1, minus vars, y vars function y2. Like I'm not going to type out the equations, and then hit dx, and then hit enter, and you get 0.5909. And that represents the area of the region between them. For part E, it says find the volume of the solid found by revolving this around the x-axis. So now we want to revolve this around the x-axis. When you're asked to find volume of a solid, then you are using area of a circle. So I know my volume is going to be some sort of pi r squared equation. So I need to find the volume of the radius of this. So it's r squared. So we're going to find the volume of the first function and then the volume of the second function and subtract them. So volume would equal pi 0, 2.9419. And the only difference here is we're taking the radiuses, which is the radius of the first curve and the radius of the second curve, and subtracting them. So like here's radius 1, here's kind of like our radius 2. So since we just want it to be this length, I have to take away this. So it would be y1 squared minus y2 squared, because it's always going to go from the distance of the x-axis dx. So I don't have to do a whole lot. I can actually go back to my calculator screen. And now I'm just going to hit second insert. I'm going to add in my squares. Hit enter. Now, I'm not done because I didn't multiply by my pi. So I have to add my pi either at the beginning of the integral or at the end. And we get 1.7466. We get to eliminate f because it's around a different line, which would make it a washer method, and we are not doing washer methods this year. And then the last one is the cross sections perpendicular to the x-axis. So we've done cross sections a few times recently as well. So if it's a square, then we need to find S. So in this case, S is going to be the top curve minus the bottom curve. So it'd be like y1 minus y2, because again, that would now give you this length in here. So S would be the point here to the point there, which is top minus bottom. So the volume of region R is going to be the integral from 0 to 0.9419 of s squared, which is y1 minus y2 squared dx. So on your calculator, you're just going to go back up. I would probably go to this one, and then at the end of my parentheses, hit second insert square, and actually it looks like I'm going to have to add my own. So I have y1 minus y2 squared times dx, and I get 0.461. And then H is BC, which we're not in. So that's the conclusion for today. There is a circuit training on there. It's only a couple questions, and then I made a delta math for you. Circuit training's all calculators. So really you're just kind of, working through the calculator. Determine the slope of the line tangent to blank at blank. So that's math 8. Type in this, type in that, get a number. So I'd write your number here because that's what I did. And then we can go through and check our numbers tomorrow. So you're going to do those 2 pages and then the delta math. And that concludes your day and our wrap-up study of how to use a calculator on the AP exam. Questions for me?
Can we look at the one on the circuit that has solution 170.306?
Solution 170. So like this one?
Yep.
Okay. So it says, given the function from blank to blank, determine the value of the derivative. All right, so this is actually a fundamental theorem of calc question. Because if you're given the function and now you want to find your derivative, if you think about f prime of x equaling d dx of an integral, then like the dx's cancel. And I bet you, so remember that this, when you take it, you plug that in. So it becomes f prime of x equals e to the 3 times 4x plus 1 square root. But then you have to also multiply by the derivative of 4x because its derivative isn't just 1. So like 4x goes in for x, but then you have to multiply by 4. So then f prime of 3.5 would come from plugging that into your calculator. Yeah, and that's like a really, really, really big number. Did you miss the 4?
Yep, that's exactly what I missed.
As soon as I wrote it down, I was like, yep.
Thank you.
You're welcome. All right, guys, I'll be available on Teams all day if you need me. So if you get stuck on a different question, I'm trying to grade through some of your papers today, get some stuff ready for tomorrow. But I'll be around if you need me.
Thank you. See you.
Bye, Maddie.